Hello, hello, everyone. We're going to give this a moment here to get started with the stream. It always takes a bit of a delay to get to everywhere where this stream needs to go. So, that being said, we are live. Welcome to the Weekly Wrangle. And, well, if you've never been here to the Weekly Wrangle before, welcome. I alternate between three things every single week. So this week we are live and we're going to be doing something special with that today. We also do professional industry interviews and we also do monologues, or I do monologues on a variety of industry related topics. So it's all three of those things alternating every single week. And welcome. It's great to have you here. So let me double check the stream. I've been changing a few things on my setup before I get going here. This too much. There we go. We are working just fine. And if you do happen to be joining, be sure to say hello in the chat. Like I said, we are completely live. So as I go along here today, feel free to add in any questions, any comments, and just generally hang out. Okay, so today we're talking about how to build a computer, and I'm going to be doing this with a budget setup, a mid-level setup, and a high-end setup. As some of you know, I just got done upgrading my own computer recently, and it's been quite a journey. It's been a fun journey in some ways, and well, it's extremely important as a Houdini artist that you have a decent computer. So that is the topic for today. Okay. Well, let me start off by sharing my screen. And the first thing that I want to bring up is something that's obvious that people don't do, but should do. And that is look up the side effects Houdini minimum requirements. This will give us an idea of what we need as a minimum requirements for a budget build. So starting with the cheap build here. Windows 11 is what you want because Windows 10 is no longer being supported after this month in October. And if we go down here, 16 gigs is required. I would say 32 gigabytes or higher is definitely a good idea with Houdini. So we'll take that as our minimum. And with the processor here, we have some complicated technical things, right? And well, I'm not going to go through this in particular. I'll show you another way of checking the processor requirements here. But there's that. Disk space, 5 gigabytes. We need at least 5 gigs to install Houdini. I would argue minimum 1 terabyte for a SSD hard drive. So I'm going to say that 5 gigabytes is not enough to do Houdini because you need to cache out files. You need to save a lot of files to your hard drive. And so we have that graphics card. Ideally, we want 12 gigabytes of VRAM or more. And, well, it looks like this might be a new requirement, actually. That could be a minimum requirement, which is a fairly high minimum requirement of 12 gigabytes of VRAM. And there we go. So that's pretty much what we're looking at here. Let's go over to another website called PC Part Picker. Some of you maybe have heard of this before. If not, this is a fantastic website that allows you to custom build computers. And the reason why I'm bringing this up is because when we get to more of a mid-level or high-end build, that's when you want to start considering this per component approach to building your computer. If you have the patience and the time to actually assemble this all yourself. You'll save a lot of money by doing so. Now, for a budget build, I actually don't recommend doing it this way, where you pick out your CPU, you pick out every part, and you plug it in. I'm assuming that if you're on a budget build, you're a bit more of a beginner in general. And so for that reason, I just don't think that it's worth your time right away on a budget build to actually go through the process of doing this, double checking compatibility, and so on and so forth. And so when I bring this up, though, this will, as a beginner, give you an idea of what sort of components are the most relevant to pay attention to. So when we think about everything that makes up a computer, this is it. We have a CPU, the cooler for the CPU, the motherboard, that's where everything attaches to, the memory, storage, video card, case, power supply, and all of this. Okay, so that being said, let's hop on over to Newegg and try to find ourselves some kind of budget build that might work for Houdini. These are all going to be priced based on the United States. However, if you are tuning in from a different country, I'm sure that your prices might be less expensive. For instance, if you're watching this from India, I imagine you can buy computers much cheaper in India than you can here in the United States. So just keep that in mind. If I see something that's $1,000, it might be $200 in your own local currency. But assuming that we're here in the States, let's take a look at some pre-built things that they have. So we'll just go to Computer Systems, Desktop Computer, and we'll just start right there. So right away, this whole thing becomes pretty overwhelming. It's not surprising that people have no idea what to do when they first encounter this sort of thing. What I would suggest doing is opening up another website here, and we'll just go to Google and say CPU benchmarks. And this is going to test the speed of a CPU in general. The CPU is like the main brain of your computer, if you don't know what that is. So it's the main place that mathematical formulas get calculated, which underlies, pretty much everything you do with computers. It's just a fancy calculator at the end of the day. So that being said, if we go to, let's say I don't know. Let's just say the multi-thread performance here. And maybe we go right there. This is going to give us a general idea of how fast some of these brains, some of these CPUs are. Now, you'll notice that we have multi-thread and single thread, and I'll talk about that difference later. But from top to bottom, these are, generally speaking, some of the fastest brains, categorized from fastest to slowest. And if we go down here, these are all really high-end CPUs. You'll eventually find an area where the CPU becomes more affordable. So here, this one here is $612. We have this one for $544. And you have to go a fair ways down this list until you start finding something that's maybe in like the $200 or $300 range. So here we go. Here's a processor for $400. It's the AMD Ryzen 9 9900X. I'm going to open that in a new tab by middle mousing that. And then I'll keep going down here and I'll just pick out a few of these to double check. So I'm looking for a CPU that's somewhere around $200 to $300. I would say that's a pretty safe bet for a general, CPU to use here. And the idea is that if I find some CPUs that are pretty darn fast for $200 or $300, like let's take maybe this one here. This is $200, the Intel Core Ultra 5. I can then go back to Newegg and see, do these computers use this CPU that is decently fast? And if it does, then I would consider that to be a decent contender for what we're trying to do here. So here we go. Let's take this one. It's about $200 if you were to just buy this. And we'll go here and see if any computers contain this. I didn't test this out prior to live streaming here, so, we'll see if this actually shows up on a computer. What we can do is we can also go up here and try to see if there is a computer filter so that we're not just buying the CPU. Maybe there is, maybe there's not. So, okay. I don't think we actually have a filter here just to show us computers that have this. Maybe if we go to, I don't know, Gaming PC Finder, And then that's not what we want, actually. Um, well, wherever you buy a computer, this is the general idea. And maybe you'll just have to take some time to actually like search this properly. But if we go here, let's try this one more time with the desktop computer. And we have, what is this? The Intel Core Ultra 5. So maybe we can say Intel Core Ultra, let's say i5. Sure. Maybe that's what we're looking for. And maybe we can keyword search this as well. So maybe we try that, or we try a keyword of 245 KF. Let's try this up here. And maybe we're lucky and it comes up here as a computer. If not, then you get the idea. But we want to start with the CPU just because that's the main brain and then go from there. Now, let me take a look at the chat here. This is from Mohammed. Sorry for interrupting, but my PC right now is R5 4500, 16 gigabytes of RAM, GTX 1060. To what extent do you think this PC will hold up? I'm still in the learning phase right now. So, yeah, Mohammed, I think that it's going to work for a little bit, but in general, you do need to upgrade that at some point. Perhaps not right away. I mean, try it out. See if you're running into limitations, right? What I'll say in general about computer specs is that people get really hung up on this, and often it's not something that you should get hung up on because a lot of things in Houdini can get done with slower computer specs. And so it's nice to have good computer specs, but is it necessary? Not always. It is going to be necessary once you get to really dense and intense simulations, right? But many situations in Houdini don't call for that. And you can certainly learn in the meantime with a slower computer. So I also just want to mention that to everyone here, because that's a common misconception as well. You don't need like a $3,000 computer to get started with Houdini. Oftentimes what you have is very good. As a matter of fact, I built CG Forge for like 7 or 8 years with just like a half working 1080 graphics card and like a super old processor. And I did that somewhat intentionally just to prove a point that you don't need crazy computer specs to make good looking renders and to do the job. So yeah, great question there, Mohammed. But anyway, back to what we're trying to do here. Let me try one more thing. Maybe we can search this and have some luck with finding a computer that uses this. And yeah, maybe, I wish Newegg had a better filter situation going on for this here. But regardless, it's just kind of a bummer here. So AMD Ryzen 9, let me just try one more thing before we, call this a done deal here. Go to computer systems, desktop, and we go to CPU type. Let's try the Ryzen 9, and maybe we should try finding it here. Okay, so the Ryzen 9000 series. Great. Fly. Okay, and then I bet you what we can do to find this specific processor is we can just go sort by lowest price, because this is probably the cheapest one that they have. And there it is. Yes, the Ryzen 9 9900X. Okay, great. This here is $1,600 for the pre-built. And a lot of what you're paying is for the case. It's for the GPU, I believe this comes with. This is a bit more of an expensive option here with this pre-built. But try going through the filter process like I just did on the side. I know my face was blocking that, but anyway, you guys get the idea. Start with the CPU. Once you have the CPU, everything else sort of revolves around that. Your motherboard needs to be compatible with the CPU. The cooler needs to be the right size for the CPU. Everything is based around the CPU. So that's why this is a good place to start. And so, again, budget build, find yourself a decent CPU, try to filter things out, And then look for something that has at least 1 terabyte of a SSD hard drive. SSD is the type of hard drive, and it makes it faster to read and write files when it's an SSD. So you want that. And then, as well as finding a graphics card with 12 gigabytes of VRAM, as the minimum specs suggest in the documentation, or the in the side effects system requirements page. So yeah, that's what I would do. And you could probably get away with some research on this with maybe about $1,000 to $1,300 for a budget PC build that will last you a good while. So yeah, in general, I would say that's what you should look for if you're on a budget. And additionally, it's nice to buy a pre-built because you have, let's say, a computer store or an online store to go to if something's ever wrong. So let's say you get a computer, something doesn't work after a couple of weeks of using it. It's nice to take the whole darn thing back to the store or to contact wherever you order this from and have customer support help you if something doesn't go right. So that's why I think that if you are a beginner and you're looking for a budget system, that's the way to go. Don't confuse yourself with anything more than that. Find a decent CPU, 12 gigs of VRAM for the graphics card, and at least 1 terabyte for an SSD, and you're good to go. Where things start getting a bit more interesting is when we talk about more of a mid-level setup. Because once you get past the pre-built situation, you're going to start saving a lot of money by picking out every single part that you want. And well, this is where things get naturally a bit more complicated. And as well, I will say that if you don't want the hassle of building your own computer and you do want to pay extra for a pre-built setup, that's a perfectly legit route to go as well. It just depends on how much money you're willing to spend if you want to pre-build this thing or have this thing pre-built for you. I will say that once you get to the higher end setups, you're going to be spending thousands of dollars just on someone else building your computer for you, rather than you building it yourself and just ordering the components. So I do think that if this is something that you're doing professionally or seriously for, into many years into the future, you do want to learn how to build your own computer eventually, just because it really does save you thousands of dollars if you figure out how to do so. Just my personal opinion. And that's also why I build my own computer as well. About every like 8 to 10 years, I build my own PC. So that being said, for the mid-level, I would start again with the CPU, find something that's maybe, I'd say like $400 to $700, somewhere in that range. And the other thing that I want to mention is that we are looking at the multi-thread performance right here. And you can also look at the single thread performance as well. And that's very important to consider once you start getting into this $400 to $700 range. The difference between multi-thread and single thread is essentially this. That brain in your computer can think about multiple things at the same time. That's the multi-thread performance. When it has multiple tasks that it's calculating, they call it in parallel, so at the same time. And compare that to a single thread, which is you have, let's say, your CPU, and it's thinking about one thing, and it's not thinking about multiple things at the same time. Many things that you do in Houdini are going to be single-threaded, so it's not going to be multitasking its thought process, if you will. It's just going to be thinking about one thing. It's single-threaded. And many things are going to be multi-threaded. So if, let's say, you're going with the CPU render engine, like, let's say, Arnold, as an example, that is going to be all about multi-thread performance. It's all about thinking about multiple areas of the image at the same time when it's rendering. Whereas single thread performance might be if you're dropping down a remesh node in Houdini, that particular node was not made for multi-threading. So it's one task at a time that's being put onto your CPU. Ideally, as a Houdini artist, you want to have something that is decent at both of those things when you are looking at a mid-level setup. So when you do your research here, you want to look at the single thread performance, and this is actually where I would start. And then you want to see if it has decent multi-thread performance. And as long as the multi-thread performance is decent and your single thread performance is pretty good, I would say that's an excellent way to find a mid-level CPU in this case. So, and this actually is what I did for my own build, by the way. I just went through here and I started looking at these single-threaded performance CPUs. You'll notice that the pricing is actually pretty good here for single-threaded. And then I just, let's say, took this one, the Intel Core Ultra 7 265KF, this catchy thing. And then I went to see, okay, this has great single-threaded performance. How is the multi-thread? And if the multi-thread's decent, so I'll just copy that name. I'll go here and I'll keyword search. We're at a 58,000 score, and frankly, that's pretty good. It's still on this list, which means that it's a pretty decent multi-thread performance. That's a good deal, right? Because decent multi-thread, really good single core performance, that's exactly what we're looking for. So in this case, let's say that we want to do this CPU, the Intel Core Ultra 7. That's where I would go back to PC Part Picker, and I would start filling this out. And let's see if we can find it. There it is. And we're going to add it to our component selection. Now, like I said, everything revolves around the CPU. So from here on out, if we get a cooler, if we get a motherboard, if we get anything, it's going to need to be compatible with this brain, this CPU. And that's the big thing that we're looking for here. Before I get into that, let me look at the chat here. This is from Mustafa. Hi, I've uploaded myself last February after 9 years with the Ryzen 9950X, tons of RAM, 192 gigabytes, and a 5090. The most difficult part was finding 192 gigabytes of RAM to work with a dual channel Ryzen 9950X. Yes, and RAM compatibility is something we're going to get into with the more advanced considerations here towards the end. Yeah, finding fast memory is a big deal. And also paying attention to your PCIe lanes is a good advanced consideration as well. For now, though, let's keep going with this mid-level build. So essentially, all you do is you just pick out each component. What we're looking at here is going to be compatible with the CPU. And that's the great thing about PC Part Picker. I don't have to go and figure out, you know, amongst the 400 different cooler options, which one's going to work well with this CPU. It's going to figure that out for me, and that's really fantastic. The main decision here with a CPU cooler is, do you want to have a closed loop liquid cooler? So in other words, water runs over a copper plate that's over your CPU. It picks up the heat, and then it brings it through a radiator that pushes the hot air out. That's what a liquid loop does, essentially. So that keeps your CPU cold, your brain cold, if you will, which helps it run fast. Or do you just want to do an air cooler? So an air cooler is similar. You have a copper plate, it goes on top, but instead of running water over that copper plate, we are just running it through a series of essentially radiator fins, and then a fan is blowing that heat outwards. Air is going to be a lot more cheap than a closed water loop, and arguably air cooling is going to be more long-lasting than a liquid loop. However, if we go for the liquid, that is going to provide better performance for a cooling situation. The other thing that I want to mention when it comes to finding the right cooling option here is that this is going to have a big impact on what sized case you need to have. My expensive build that I'm using right now uses a massive closed loop liquid cooling situation. It's the Arctic Liquid Freezer 3 Pro, but I have the 420 version instead of the 360. What that means is that I literally have a huge, massive radiator that's going to the top of my computer case. And for that reason, I need a massive computer case. So depending on what you choose here, it could take your computer case cost from $100 up to, I believe I paid nearly $300 or $400 for this computer case because it had to fit the cooling option that I chose. Just something to keep in mind. Yeah, in this case, for a mid-level build, let's just go with air cooling to keep this simple for now. In particular, I found by looking at some review channels that, well, I think it's this one, if I'm not mistaken, the Nocta. This one had really good cooling performance for a fan. I do want to bring up something real quick that you can look into when you have more time. It's a fantastic YouTube channel if you've never heard of Gamers Nexus. So let me pull up his channel. This is probably my favorite review channel that goes into all of these different things. And so Steve, the host here, he's been doing it for a long time. He knows his stuff. And as a matter of fact, if you want even better benchmarks than what Passmark has to offer, his channel has it because they do tests on different applications. And it's not just like a general score. So as an example, if we do cooling as a keyword search, you can go through, look up specific coolers, right? Liquid versus air, deep dive test. This one's fantastic. And this gives you actual benchmarks of how well these different components cool down a CPU. So I'll put this here in the chat if you guys are interested in looking at that. But yeah, you can spend a lot of time researching this, having fun, right? That's part of it, is just learning about it as you go. But for now, let's just take, I don't know, one of these fans here for like, we'll go a little bit more than 20 bucks, 25 bucks, sure. The motherboard. For a mid-level build, I wouldn't worry yourself too much about finding the absolute best motherboard you can. Find something that's not the cheapest, find something that's not the most expensive. For a mid-level build, I personally like MSI, but that's not the only brand that you can do. Asus is awesome. Pretty much most of these, the AS Rock can be pretty great as well. But let's just say this first one here, the Tomahawk Wi-Fi, add that in. We'll talk more about motherboard considerations at the very end here. For memory, whenever you buy memory, you want to make sure that you buy everything you want in one package. So adding on memory later on, it's actually not, it's possible, but it's not the most ideal way of doing it because memory is designed to be compatible with from one stick to another. So as an example, if I want my computer to have 64 gigabytes of RAM, which I think is pretty ideal, right? I would just go here and I would buy it straight up. I wouldn't plan on getting 32 gigabytes now and 32 gigabytes later. I would just go straight for the amount of RAM that I want. And if I get new RAM, I'm just starting over with brand new sticks. The reason why is because when you have sticks of memory, the read and write speeds, so how fast stuff goes on the memory and how fast stuff goes off the memory, is tuned in by the manufacturer for each individual stick. So if I get two sticks here for 64 gigs, these two Vengeance components right here are designed to have similar read and write speeds, and that provides better system stability. You're less likely to run into blue screens. You're more likely to get the most speed out of your RAM as well. That's how you combat that. You slow it down so that if you have mismatched RAM sticks, it doesn't crash your computer. But anyway, that's all to say, pick the RAM you want. I'd say 64 gigabytes of RAM is pretty great for a mid-level build. And let's just do this one, these Tridents. Sure. The memory is a big deal. I will say that I found that it can make about like a sometimes 30-40% difference in speed for some applications and for some things that you're doing. So RAM is important. But anyway, We'll talk about that more in a bit. Storage, this is going to be your SSD drive. Now, this is an area of confusion. If you've never heard of the difference between SSD and HDD, that's something you need to figure out here. SSD is fast. You can read files, you can write files really quickly, and that's going to be big for Houdini because you're going to be caching out simulations, saving out lots of data, reading lots of data from your hard drive. This makes one of the biggest differences in speed when you're using Houdini, just because as an application, it's reading and writing files all the time, really quickly. And so anyway, that being said, any SSD will do as long as it's an M2, meaning that it looks like this. This is like an M2 SSD. If you find SSDs that look more like a hard drive like this is not going to be as fast because it's limited by the actual way that it's connected to the motherboard. So I would suggest finding an M2 SSD. This 9100 Pro is incredible. I believe that's what I have right now. But I have like the 4 TB version. But yeah, ideally for a mid-level build, I would say try to get something that's 2 TB. If you go for the 99 or the 990 Pro versus the 9100 Pro, you're going to see a difference in speed if your motherboard is compatible with that and your CPU is compatible with it. For the most part, though, I would say for a mid-level build, go for something cheaper as long as it's, again, an M2, it looks like a chip, and it's an SSD. Okay, so there's that. Video card, this is your graphics card. That's going to affect how fast your viewport is in Houdini. And it's also going to affect if you're using a GPU render engine like Redshift, or if you're using Karma XPU, the GPU portion of that calculation is going to depend on your video card. So this one's actually quite important, and many simulations can also be done on your video card as well. So I would say if you're going to spend a little bit of extra money, try to put it towards your graphics card here. Find a CPU with fast single core performance, and then spend a little bit more on your GPU. And that's going to be a good way of spending your money for like a mid-level budget here. So in this case, there's all kinds of different ways you can do this. The GeForce series are great. This can get complicated once you start getting into multiple graphics cards, and that's something to consider. But let's see if there's a filter here for VRAM, because I know that was a big deal here for the minimum requirements. So let me just see on the side if we have VRAM. We do not, unfortunately. Well, that's okay. VRAM is a big consideration. Also consider the actual size of the graphics card. What I have right now in my computer are two 4070 Ti Super graphics cards. And the nice thing about them is that they're small. They're not massive. A lot of times, if you do get like a massive, I don't know, like 3090 graphics card, you'll actually need to have extra supports to make sure that it doesn't bend the input over time because it's so heavy and large on the motherboard. And so that could equal a more expensive case, as an example, to support a large graphics card. Anyway, that being said, oh yeah, here's the memory right here. Yeah, okay, so don't do anything that's 8 GB of memory. Do something that's 12 or more. And let's just take the 3060. This is a nice mid-level card, I'd say, right now. Add that in. If you're curious about graphics card speeds, you can also go back to Passmark, and we do have video card benchmarks as well. This gives you an overall idea of how fast these different graphics cards are. So find the fastest graphics card that has enough VRAM and has a decent price, and you can just go from there. I would say try to aim for something that's like, I don't know, maybe $250 to $500 or $600 or so for the graphics card. Now, again, this gets complicated when you start considering multiple graphics cards in the future. I have 2 graphics cards running, And that could be more complicated because your motherboard needs to support that. It needs to have enough physical space between the PCIe slots. That's where you plug in your graphics cards. But for now, let's just say we have one graphics card. That's fine. You pick out your case. You can go crazy on this, but I don't suggest doing so unless you absolutely have to. Let's just go for this nice Corsair 3500X just because it looks cool and it's nice. And then it brings us to the power supply. My favorite way of figuring out power supply requirements is just to ask ChatGPT, quite frankly. So as an example, if I go to chatgpt.com real quick, and let's just go here. You could say, I am building a computer and I need help finding the right power supply for my components. And then you list out all of your different components. So, we can go through here and just copy and paste. So I'll just copy that. I'll say CPU equals this. And I'll say GPU equals, where is it? These are the two things that are going to take the most power to run. And then I would just go through each one of these. And then when we upload this, take the time to actually copy and paste everything you have here. And then whenever you find the estimated amount of power that this needs, always add a little bit more. Additionally, if you plan on adding another graphics card in the future, you'll want to buy the PSU, the power supply that will support the extra graphics card in the future. So here are some different things. It takes about 650 watts to run this. If you want another graphics card in the future, you need to bring this up, but it's all about wattage. So look for the wattage on the component itself, and that lets you know how much power you need from your power supply. This should have everything compatible, and we have the bronze, gold, platinum. I would say go for like platinum or gold if you can. Don't do bronze. That's just like a general quality of the electrical components that are put in there. It's a little bit more expensive, but worth getting. I would say gold in most cases is probably just fine. So let's add that in there. That's going to be $86. And then you have Windows and you have your computer monitor. And of course, if you want, keyboard, mouse, all that would be in addition. So here we have a build. It's about $1,500. You'll notice that the budget build that goes for a pre-built versus a mid-level build can actually reach about the same price. But the mid-level build is going to have much, much better components in it because you are assembling it yourself. That is, in my opinion, what makes something more of a mid-level build. And that's the process I would generally go through if you wanted to do so. Do keep in mind that as you're building this out, ChatGPT is your friend, and it is going to take some research. That's part of the fun here. And I do suggest also looking at some Gamer Nexus reviews to see which components you want to use. So that is a mid-level build. And that naturally brings us to, what do you do if you have a great budget to work with and you want to spend anywhere from like $3,000 to $5,000, right? This is what I just got done doing. I saved up money over, 7-10 years, right? And I just decided, you know what? I'm going to be using this thing every single day for the next 10 years. And I just want to use whatever is the best right now, like reasonably the best, and just use that for a long time. So if that's your mindset, then what's the process look like? Well, it's everything that I just showed you here. Except now you need to start getting a little bit more into the weeds, a little bit more into the details to really optimize this as much as possible. So going back to the CPU, some more advanced considerations might be, okay, find good single core performance, find good multi-thread performance, but also find a CPU that's going to have a nice compatibility with a modern motherboard as well. Because I think where things get a little bit trickier on an advanced build is in the motherboard selection. And yeah, I'll talk about that here in a moment. The CPU that I ended up going with here is, where is it? Yeah, I believe I did the 9900X here for about $400. And the reason why I chose the 9900X for $400 rather than a multi-threaded CPU that could cost upwards of like $10,000 or something, right? Number one is because I didn't want to spend $10,000. But number two is because even if I could spend $10,000 on it, it really wouldn't be taking care of the tasks that I care the most about, frankly. And in my opinion, when I'm looking for a CPU, that's going to help me with my day-to-day tasks with using Houdini. So like setting down a node and waiting for that node to cook if it's single threaded. Situations like that, in my opinion, is where the CPU shines the most if you are relying on a GPU render engine like I am. I'm using Redshift, so most of my render time, most of my computer processing time is going to happen on the graphics card anyway. And so if that's the case, I want fast single core performance just to help out with the day-to-day tasks. And that's the biggest thing. Actually, I didn't get that one. I got the 9950X right here. So I got the one notch above that here. All right, this is from Pashab, getting a Ryzen 9 7900 and then a 5060 and 64 gigabytes of RAM for $1,400. Yeah, that's awesome. And like I said, if you're not in the United States, you get way better deals on the price of all these different components because they make it cheaper depending on your country. So yeah, I mean, those are awesome specs right there. That's definitely doable for Houdini. So anyway, that being said, that's why I chose this one. Now, there was a consideration, like, should you do the 9950X 3D or the 9950X, like the regular one? And this was a debate that I did some research on. If you want to get into the details as to like why you might spend $100 to $120 more, it essentially comes down to this. Are you going to be using L3 cache on your CPU for video games? And if the answer is yes, then the 9950X 3D might be the way to go. If you are not using it for video games and you're using it for production tasks like exporting videos or for running Houdini and stuff like that, which is what I use my computer for, that's going to be better with the 9950X because it doesn't prioritize the L3 cache. And if you don't know what L3 cache is, it's essentially a portion of your CPU that's used for specific tasks. So a video game is going to use more L3 cache than, let's say, Houdini is. And so to get that extra L3 cache, it's going to be application specific and it's going to be task specific as to where you get the benefit. For that sort of detailed analysis, that's where I think Gamers Nexus is going to really be your friend because they ran those benchmarks and you can really see like which tasks for which CPU perform the best. This is another question here from Mohammed. So what should I mostly focus on when building a GPU or what should you focus on, GPU or the single-threaded processor? You need to have both. That's the short, long answer of it. I would say I prioritize the GPU in my workflow because I'm not relying on CPU render engines as much. And a lot of times too, when I'm simulating something, I'm doing smaller simulations with my scene. And a lot of those smaller simulations can benefit from the speed I get from my graphics card rather than the speed I get from my CPU. If you're doing something that is much larger scale, like let's say you're building a computer farm for a studio, you might want to consider getting something that's more CPU based. because your massive simulations might get limited once you start trying to load entire scenes onto VRAM. So that 16 gigabytes of VRAM, it's like how much stuff can you put on the graphics card? If you're doing massive fluid simulations with like a billion particles, you're not putting that on a graphics card. You need to rely on your RAM to put it on there and then use the CPU for calculation. So depending on the kind of work you're doing, I would say most everyone watching can benefit more so from GPU because you're not doing these massive simulations amongst like multiple computers on a farm. And so for that reason, anyway, yes, to answer your question, GPU. Okay, so as I was saying here with all of this stuff, yeah, L3 cache, that's why I went with the 9950X. It's a really fast single core performance, and it's also pretty good multi-thread performance as well. If we look at the 9950X, the 3D has better multi-thread performance, but it's not far behind down here at a rating of 65,000. So really fantastic multi-threaded performance for its price. I mean, look at these other CPUs. They're like $2,500, $3,000 CPUs that have similar multi-threaded performance to the 9950X. And so it's really just a fantastic bang for the buck. And I'm going to spend more of that money on my GPUs, on my storage, and everything else. That was my thought process. Then going for the cooler, this is something that I spent more time on because I also, being that I had a single threaded or a single threaded performance CPU, I know that that's going to get a little bit hotter than a multi-threaded CPU. Like it's going to get hotter more quickly because it has a very fast gigahertz. So when you go here to, where is it? The 9950X. Okay. Well, hold on a second. Let me find this. Oh, that's the video card benchmarks. All right. So if we go to the 9950X, which is, oh, come on, down here, we can see that our turbo speed gets nearly up to 6 gigahertz, which is really, really fast. And when it goes up to 6 gigahertz, that means the temperatures rise really fast as well. That's why I went a bit more aggressive with my cooler. The thing is that when your CPU gets hot, it's going to slow itself down in order to prevent itself from overheating. So it's going to naturally just kind of dial it back as it gets too hot. And so what I wanted to do is spend more money on an incredible liquid looped cooler here. And for that, I went with the, where am I at here? I went with the 420 radiator that I was talking about earlier, that massive thing, right? So the Arctic Liquid Freezer 3 Pro 420. Which is not even on here because it's a newer line that Arctic has. Like it just came out fairly recently. That being said, that took my case up a lot higher. Instead of paying like $200 for a case, I'm now spending like $500 or $400. And that now is able to fit everything. But yeah, more money was spent towards the cooling of the CPU and the case itself. Now, my graphics card, like I said, is a 4070 Ti Super, and I have 2 of those. Now, when I bought that GPU, I also timed it so that it was right around when the 50 series first came out. And the reason why I time it that way is anytime NVIDIA comes out with a new line of graphics cards, the old gen gets price cut a lot. Usually it gets price cut quite a bit. So when I got the 4070 Ti Super cards, okay, that's not what I wanted. All right, hold on. 4070, that was annoying. Okay, 4070 Ti Super cards. It was actually cheaper than what you see right here. I got it for like, yeah, I got it for about this price, actually, like almost $700 per graphics card. And that's because the 50 series just came out. After it came out, the 50 series was kind of a dud launch. compared to the 30 series launch and the 40 series launch. So they actually took those prices back up for this card afterwards. But my thought process was, okay, I don't want to blow my power consumption out of the roof. And frankly, if I have two graphics cards, I'm essentially doubling my speed, right? Like when I'm rendering, I'm doubling my speed because I have two buckets now that are going to be working on the image. So I'm not going to get the most expensive card that I can find, just because I'm going to be paying a lot more for performance that isn't like as drastic. So I went for something that's still pretty nice, kind of like mid-high tier, but I didn't go for the most expensive just because I'm going to do two of them and I wanted to get the best bang for my buck. So that's why I went with the 4070 Ti Supers here. And they've been really fantastic cards so far. I've been really happy with them. The other thing that's nice about them is that they are smaller. So the one that I have is actually quite small. So it looks more like this. I didn't get the Asus version, but it looks pretty much just like that. It's about, I don't know, this big or so. And the nice thing about that is it gives me a little bit more room to put in other things inside of my CPU or inside of my computer as well. So there you go. The other spot that I spent more money on was the motherboard. And this is where things get a little bit complicated because you have to think about PCIe lanes. Before I get into that though, let me look at the chat, make sure we're good. This here is a question. I have a query. VOPS is easier to learn or is VEX easier? VOPS and VEX are essentially the same. It's just one uses nodes to create VEX and VEX is just typing out exactly what you want to do. I wouldn't call one or the other easier to learn. I would say that you need to learn both. And I would suggest starting with VEX and then learning VOPS if you had to pick an order to it. But anyway, back to this situation. When I'm talking about motherboards, what do you look for? Let's just go to MSI's website real quick. So MSI motherboard. And things start getting a little bit complicated once you start looking at this for the first time. But let's just go and take a look at what I got here. So if we go to motherboards, let's take the AMD motherboards because that fits a CPU that I just got. And these are all the latest gen motherboards for AMD CPUs. Again, double check that the CPU you get is compatible with the motherboard over here. But we have anything from about $1,000 for their like crazy high-end line, this godlike line, down to maybe $100, $200. And so what's the main difference? Well, the main difference comes from PCIe lane routing. It comes from which components you use, and it comes to extra bonus features like do you have built-in Wi-Fi as an example, or how many or what kind of ports do you have for USB, or do you have like USB-C ports and stuff like that. So what I actually ended up doing for this is I went for the gen before whatever's the latest. I'm a big fan of that. Just if you want to save a lot of money, just go for one gen before the current generation of whatever it is, and you can usually find really good deals. More specifically, I went with it was the MSI 670E Ace motherboard. This one, which used to be their godlike motherboard that was like $1,000. But because they were just trying to get rid of inventory, instead of paying $1,000 for this, I spent like $450. So you could save a massive amount of money. The difference between this and the current gen is mostly going to come down to future compatibility. So if I want to add, I don't know, if I want to change out the RAM in the future, if I want to, I don't know, like add another or change out the graphics card 10 years from now, okay? That's going to be a bit more compatible with the godlike versus this $450 version. But in my opinion, for saving like half the money, it's worth it. If we go here, the motherboard is going to determine, again, which inputs you have. So like if we zoom in here, I have USB-C input, which is nice. I like that because I have a nice video capture card that I'm using to make sure that everything has enough bandwidth to get through to the computer just fine. It's a little bit overkill, frankly, but yeah, it has all the inputs I want, and it has nice components. And most importantly, has the good PCIe routing. Now, it's a bit difficult to find info on PCIe routing, so let me just explain it visually here. When we take a look at this motherboard, you'll notice that we have these 3 slots. Those are the PCIe slots. That's where your graphics cards goes into. And you either have 8 or you have 16 lanes for PCIe. In other words, that's how much stuff can get onto and off of your graphics card and how quickly can that happen. If you have 8 lanes, think of like a highway. You only have 8 lanes on a highway for information to go to your graphics card versus 16, where you have twice the amount of space on that highway to get info onto your graphics card. That's going to be a PCIe lane. And with these higher end motherboards, you have more 16 lanes, and you also have more dedicated lanes for all of this. So this first top lane that we're looking at right there is a 16 lane, and it's going straight to the CPU, which means that my 4070, the primary graphics card, has a dedicated lane. It's not sharing it with anything, and it's going straight to the graphics card with the full 16 width, if you will. Also, I have an M2 slot on the right there. So on the right-hand side, you'll see that Lightning Gen 5. That's where my SSD goes into. And when that goes over to the CPU, that also has a dedicated lane. I believe that's a PCIe lane 8. It might be 8 or 16, I forget. But that all goes over to your CPU, and that is not sharing it with the GPU. So when information is going to and from your CPU and the components, sometimes that shares the same highway if it's a shared lane with 16 or 8 with the PCIe. All of this is usually found in the documentation of the motherboard that you're looking at. These 2 lanes down here are, I believe, 8 lanes. But the main thing that sold me on this motherboard was the fact that I have a dedicated 16 and a dedicated 8 going straight to the CPU. They're not sharing, and that's definitely nice when I'm trying to run big scenes for rendering. What that means in Houdini is that when you hit the render button, you're going to get a faster time to first pixel. It's not massive, but it is, fairly decent for larger scenes. All of that stuff that I'm sending to the graphics card is going to be fast. It has a full 16 lanes that it can use. If I'm reading caches from my hard drive to create the Redshift file that is being uploaded to the graphics card, that also has its own dedicated lane, and nothing is slowing each other down in that process. So that's what we're looking at here when we have the dedicated PCIe lanes. Someone said here, this is all gimmicks and consumerism scams. Well, you know what? I will say you are half correct. Not entirely correct. Because when we are doing things as Houdini artists, we are not the average user. We're not the average consumer. I would say for the average consumer, this is overkill and it's something you don't need to consider. But if you are a Houdini artist and you're rendering massive scenes and every second of optimization gets multiplied by the number of frames that you're creating, then yes, 1 minute, 2 minutes, 3 minutes difference can make a massive difference in the overall scheme of things when you're making projects and rendering them out. So I agree that many of these things are gimmicks for your average person, but you are not the average person if you are a Houdini artist. So in that sense, I disagree. Okay. Anyway, that's all I'm saying here with the motherboard. Look at the PCIe lanes, look at the inputs, make sure that that lines up. And then when you go to memory, you also want to start thinking about what gen memory you have. So are you using DDR5 or DDR4? That makes a big difference in the speed of how things are read and written to the RAM. And so for my memory, I went with 200, I think I have 256. Yeah, I do. 256 gigabytes of RAM. It's a lot of RAM. You don't need 256 gigs to do most things, but I just wanted to be future proof for the next 10 years, just in case. I did spend a good amount of money because it's also DDR5, which is like the fastest RAM you can get right now. One thing about RAM, though, that you have to keep in mind is that when you get your memory, you need to tune it to the proper speed in your BIOS. So when you boot up your computer for the first time, it's going to use a slow speed for your RAM to ensure that nothing crashes and blue screens out. So what you have to do is you have to make sure that for this motherboard, it supports the right speed of RAM. In this case, the MEG X670E Ace does support DDR5. However, because it was last gen, it supports it only with a BIOS update. And so in order to support this much RAM on that motherboard, I actually had to flash the BIOS, update that first, and then from there, it fortunately recently came out with an update that created a stable profile for these RAM sticks that I have in here. So just double check the RAM compatibility. A very easy way of doing that without digging through the documentation for days on end is just asking ChatGPT. So, I would just literally go down here and say, I'm looking at this RAM, I'm looking at this motherboard. Are there compatibility issues? And this is a fantastic way of doing that. Whenever you ask something in ChatGPT, ask it to provide sources and then double check yourself to make sure that in the documentation, it does actually support whatever you're looking for. So that's what I did for memory. Storage, I did a 4 terabyte 9100 Pro. Because I am using a PCIe Gen 5 port on my motherboard, that means I'm able to take advantage of the full speed of the latest SSD speeds. Keep that in mind as well. If your motherboard has a earlier gen of PCIe, you getting a faster SSD drive is not going to work unless it's compatible with that gen of PCIe. So this is PCIe 5. So it says Lightning Gen 5. It means it's the latest thing right now. And that means that when I got the 9100 Pro, the speeds that are advertised are actually what I'm getting because it's not bottlenecked by this type of port. So you got to check the port on the motherboard with your SSD, make sure that that's good. And then 2 video cards, check the power supply usage. I believe I have like a 1200 power supply, 1200 watt. And then everything else from there is just, keyboards, mouse, all that kind of stuff. Okay, well, if you're still hanging in there, a lot of interesting stuff, right? I mean, I personally have fun geeking out over this kind of thing. It takes practice, it takes time. If this is your first PC build, I would just focus on going to PC Part Picker here, finding some decent stuff and putting it together. You can do so for like $1,500, $2,000 if you're here in the States, even cheaper if you're out in India or elsewhere in the world. Then, if you're going for an absolute top-of-the-line setup, learn more so about motherboards, all the different ports that you have, the different lanes that are created. Try to save $1 by going for 1 gen before the current gen. And if you don't want to save $1, that's fine too. But one thing as well, I will say about the latest gen graphics cards, the latest gen everything, is that sometimes you are somewhat of a beta tester as well. Because something just came out, if there's issues, often they're not discovered until it's released to the general public, and then they kind of scramble together to put better drivers together and better this and that. So by buying 1 gen before, or 1 gen before the latest, you kind of are not part of that guinea pig stage with some of these components. And I would just keep that in mind. My first build, I bought a CPU cooler that was like that. It was a total dud. It was a new product. I don't even know if the company exists anymore. But yeah, it was experimental. It stopped working within like a couple of weeks, and I was out like $300. That's it. I tried to get my money back, but the company wouldn't do it, and it just was a tragic situation. So just keep that in mind whenever you're thinking about the latest components. And if you're just joining the stream, don't forget that all of these high-end components are nice to have, but often not necessary. So don't let it stop you from learning Houdini. Don't let it stop you from getting started. This is more like, hey, you're a professional 3D artist. You're doing this for the next 10 years and you want to make the most of your money and still have the specs that you want. This is the way to do it. All right. Well, that does it for today. Again, today was a bit of a special Wrangle. Normally we do art reviews, and I want to give a shout out to everyone that just got done with the CG Forge Beginner Bootcamp. Let me pull that up real quick. If you don't know, I just got done hosting a beginner bootcamp, and it was awesome. A lot of really cool projects that people came up with. This one is pretty fun. And yeah, congrats to everyone that followed along. Thank you again if you're watching and you followed along with the bootcamp. A lot of awesome projects came out of this. And yeah, it was a good time. I'll be sure to do the bootcamp again in the future. This was like a first round of this. And I think it turned out pretty good for like version 1. But over time, I'll be doing beginner boot camps in the future again as well. And yeah, it'll be great. Besides that, a lot of great things are coming up soon with CG Forge. What I'm doing right now is I'm going to clean up some old videos and sort of consolidate things that are happening at CG Forge. I have a lot of videos that are 3, 4, 6, 7 years old. Some of them are still up to date. Some of them are getting out of date. And so I want to clean that up, update some courses by the end of this year, make sure that everything is fresh and ready for Houdini 21 and compatible with everything. And so that's what's coming up next. I also have some other projects that are unannounced that I'm also working on. I'm having other people help me out with. Look forward to more monologues and industry interviews every single week around this time. And if you are joining for the first time, thanks for watching. And hopefully this little live video can give you an idea of what it's like to build a computer. It takes a lot of troubleshooting, a lot of learning, patience, but it can save you a lot of money and be fun if you just take your time and enjoy the process. Thanks again for everyone. Thanks again for joining. And I hope you all have a fantastic week. Take care. Oh, wait, hold on one sec. This is here from Mohammed. A question about the industry. Do you think there's still hope for effects for junior compositor positions? Yeah, there is. Check out my video of why you should never call yourself a junior so that you advertise yourself properly and you actually have a shot. But yeah, you just have to be amazing. You have to be excellent. You have to do things that other people aren't willing or able to do. And that means working really hard and making incredible looking work. All right, that does it for now. Thanks for joining, guys. See ya.